Hey, what's up, friends? We're going through some Algebra 1, X.5, exponential growth, and decay word problems. All right, so I got my little trusty Desmos calculator here on the side to help me out here. Here you go. Philip has $6 in a savings account. Wow, good for you, Philip. And 5% interest compounded annually. That's once a year. To the nearest cent, how much will he have in 3 years? So $6. I like to go bracket. Now, if you're going to grow by 5%, you take it times 1.05. And then you're going to take that to the power of how many years? 3 years. So the nearest cent would be $6.95. So 6.95. So he made 95 cents. Good job, Philip. You might want to put some more money in the bank. Here we go. Frank, $80 in the savings, 10% interest, 3 years. Okay, so the nice thing, I can go, once I have the formula set up, I basically just swap out the values. So this dude's got 80 bucks. Now a 10% growth factor will be 1.1. Remember, you have to use the decimal. Percents are pretty, but decimals do the work. 3 years, compounded annually. Double check, make sure it's compounded annually. That's once a year for 3 years. $106.48. Okay, 106.48. Got him. What? Oh, I should read the question. To the nearest cent, how much interest? Not the actual account. So here's what I needed to do, friends. I needed to finish it off by doing 106.48. So let me hit return here. Can I do return? Can I? There we go. So I need to finish it off by going 106.48 minus the initial deposit. There we go. So tricky. I'm usually... See, the reason I don't like that question is I really don't care how much I made. I mean, I do, but I'd rather know how much is actually in the account at the current moment. So that's kind of a like, oh, how much did it grow by? Well, where's it at now? So I skipped one little small subtraction step, but yeah, we got it. Okay, so be on our toes. Let's make sure we don't get that question again. And if we do, who cares? We'll fix it. Okay, you have 88 grams of a radioactive kind of potassium. Ooh, a radioactive kind of potassium. Half-life is 23 hours. How much will be left after 46 hours? Okay, so right now, go away. Go away. Can we clear some of this? Go away. Okay. So we have 88 grams. It's half-life. So that means you're going to be chopping it in half. So 0.5. And then how many times do you chop it in half? Well, you chop it in half every 23 hours. And 46 hours is going to go by. So how many chops happen? 2 chops. Okay. So that's the tricky part with some of these problems, is that this exponent number isn't just going to be flat out given to you sometimes. You need to actually calculate it. So the half-life, it's going to get chopped in half every 24 hours. How many times? Sorry, 23 hours. How many times does 23 hours go by in 46 hours? Twice. Okay, you're going to be down to 22 grams. Here we go. Okay, Nick, we're back to Nick. Interest rate, here we go. How much will he have in 3 years? Okay, this is all the money. How much, all of the money will he have? So 10% again is going to be 1.1. And they're just 3 years. 3 years seems to be their magic year number. Okay, so 13. To the nearest cent, how much will he have? So the entire money. 1331, not 1313. Okay, here we go. Okay, how much of a radioactive kind of, oh, I'm not even going to say that, antimony? Antimony? Is that an actual thing? Okay, well, it'll be 12 years if you start with how many grams, and the half-life is 3 years. Okay, here we go. Type. 0.5. Half-life problem is always going to be chopped in half. How much did we start off with? We started off with 672 grams. Okay. Ooh, I was almost there. 12 years. So it gets chopped in half every 3 years. So how many times does 3 years go into 12 years? 4 times. We almost had it right there. We were almost lucky. Oop, that's not an exponent. Now it is. Okay, 42. We're down to 42 grams. Neat. Ooh, this looks like a good one. Here we go. Round, necessary round to the nearest hundredth. Ooh, read the directions, friends. Here we go. A growing, farming conglomerate. Ooh, those are big words for me. Increases its water usage 5% every year. So, megaliters. That's a fun word. I don't say that very often. So 16,800 megaliters increases by 5%. So we're going to go 1.05. Oops, 0.5, bud. Now let's see here. That happens every year. How much will it? 7 years. Okay, there's my exponent. So not too bad. Stop doing that. Keep it as an exponent. All right, so starting amount, growing by 5% every year for 7 years. Nearest hundredth. I'm just going to copy and paste. I really hope I can. That'd be cool. Ooh, that's going to be a 2.9, though. So make sure I delete that and put a 9 in there. Got him. Here we go. The number of bacteria in a colony doubles every, ew, gross, 243 hours. Current population is that many? Ew, that's a lot of germs. Okay, we're doubling, so deep, 12 in. Ooh, that's even grosser. Okay, now watch this. Here's another trick you can do, friends. You can actually take, so this is how many times it's going to double, and here's the total hours you're given. You can actually throw that up in there like this. 2, 4, 3. So it'll actually simplify that for you. Okay. So if you take and put it on the bottom, how many times it's actually going to double, and then you put the total hours that go by, it'll simplify that for you. I think that's only like 4 times, but still, it'll simplify that for you if you type it just like this. Okay, so here we go, 63,000 double this many times, but they give you this many hours. Oh, that's a lot of germs. Ew, 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 ew. Got it. Okay. I'm probably going to leave it alone. Let's do one more. Here we go. You have this many grams of a radioactive kind of molybdenum. I feel like they're just making this stuff up. I could Google that, but I don't want to. How much will there be after 14,000 years if the half-life is that many years? Ooh, glad I have that here. Can I just select all this? Here we go. Okay, so right now you got 10,560. Half-life, so 0.5. I could do 0.5 or 0.5. Now, it halves itself every 3,500 years, and we're talking about 14,000 years. Oh, 660, isn't that nice? There you go. Yep, that's all I'm going to do. I'm going to leave you alone. Maybe I'll do one more. Here we go. Mary buys a car. Her car immediately starts depreciating. That's true. As soon as you drive it off the lot. Ouch. Oh, 23% of its value each year it's going to lose. How much will it be worth in 9 years? Oh, dear goodness. Poor Mary. Start from scratch. Bought it for $29.50. Now, if you depreciate by 23%, that means you're going to keep 77%. Yeah, I believe that adds to 100%. Remember, you don't actually use this number. You use the decimal of what you keep. And we got to take that to the power of 9 years. Oh! Oh man, 9 years. That's how much the car's worth. 1,993 and 43 cents. We're rounding to money. It's the nearest cent. 427. That 7's gonna make you a 3. Oh, okay. I'm done. That's all I got for now. These ones are getting too sciencey for me. Okay. Hopefully that'll help you with the IXL X.5. I only got to 60 in about 8 minutes here. So as long as you take your time and use the calculator, you'll get as high as you need to. And it'll just take a little bit of time, a little bit of setup. So see you in class.